All right, good afternoon, good morning, wherever you may be. I hope you're here for the right reason. This is a webinar on different paths for migrating apps into Azure, and we're going to be looking at a couple different ways that are used for migrating in apps. I'm specifically looking at apps. We're not going to be looking at a lot of things like databases and things like that today. For moving apps into Azure and just trying to understand, the caveats of those and just understand the why you would want to use one over the other. And so hopefully we'll show you what those options are and then just talk about the pros and cons of each and how that will help influence decision making as you consider moving your apps into Azure. So a little bit about me. I'm Blaze Stewart. I am architect at WinElect, and I am Microsoft Azure MVP, MCT, and a couple other things. And I pretty much live and breathe Azure all day long. So this is something that I do quite a bit about and quite a bit of. And so I use, I enjoy sharing about it. And so let's go right into this. So, see if I got a slide about WinElect. I can't remember if I included one in this deck. Next slide. I did not. But okay, just a little bit about who we are. WinElect, I didn't include the slide, but we're a consulting slash Microsoft service provider for Azure. So we do a lot on Azure as in terms of consulting services, and we also do a fair amount of training in that space as well. So we're kind of a one-stop shop for all your training and consulting and hosting needs for Microsoft Azure. So we kind of round out the whole picture there. So let's go right into the content, and we'll talk about that. So the first thing I want to do is kind of look at what a migration actually looks like, and this is talking, of course, in the kind of in the abstract right here. And there's a multiple parts of a migration into Azure. So migrations into Azure is a lot more than just moving your apps up into Azure. There's a lot more to it than that. So I wanted to kind of show the plethora of different kinds of things you kind of have to do in order to get things on Azure, and then try to zoom in on what we're kind of focused on today. So migrations start with just kind of learning about Azure, and so that's what that's all training. That's basically just getting your head around what is Azure, how it works, what are the offerings on Azure, and of course, there's a lot of different technologies on Azure. So you learn about the tools and technologies, best practices, and architecture patterns. I mean, there's no way you can learn everything there is to know about Azure. That's just not humanly possible. But you kind of get an idea of the scope of what it is, and then try to focus in on what you're really trying to aim for, which in our case today would be something like apps hosting on Azure. So I'm not going to be concerning myself with things like blockchain technology or things like that. That's kind of outside the scope. So I'd probably want to learn the things that deal with apps and that kind of thing. Then the next thing you do is you do an assessment, and we're going to kind of look at this today. Some part of this goes into feeding into an actual migration, and this is where you look at a lot of different things. You do look at your apps and infrastructure. That is where you're looking at the pieces compose your application, but you also want to consider things like business process and governance as part of that. How I run my business, what is the value that I give my customers, how do I manage my business from a governance and security perspective, what are all those kinds of things. And then these two things, you kind of take the synthesis of what does Azure offer, how do I run the business, and I then build out a plan for migrating into Azure. And that's where you frame out these kind of first three are just getting the building blocks in place for Azure. It's subscription management, roles and identity, Azure landing zone, and then once you have these kind of planned out, you kind of know what those look like. Then you kind of get an idea what your apps are going to look like on Azure, and then you build a schedule. You see the logical progression, and you build a schedule. Okay, step one, get my Azure landing zone in place. Step two, migrate my apps. And then you execute that. Then you start with your security and governance, and get your Azure landing zone in order, and then you do an app migration into Azure. And so you end up doing something that looks like this, kind of this waterfall approach. At first, it looks something like this on a timeline. You have this waterfall approach at first. You kind of do this learning discovery phase, just kind of figuring out Azure. Then you do your assessments and planning, your governance. And then this is where you start to do some implementation down here with governance, security, landing zone, and ultimately getting your apps migrated into Azure. And once you kind of got that landing zone in place, you can parallelize all of your migrations into Azure. We're going to be focusing primarily on this step with the assumption that I've done kind of everything prior to this. We'll look at assessment a little bit and a little bit of planning, but we're primarily going to be interested in different migration paths that you want to look at for moving a migration into Azure. So it's kind of this assessment planning, but primarily focused on the output from that, which is migration paths into Azure. So you've probably seen something that looks like this, where you have infrastructure as a service, and then you have platform as infrastructure as a service, platform as a service, and software as a service. So we're used to on-premise. If you're thinking about moving into the cloud, you're probably very familiar with this stack on the left here, where you're basically responsible for everything from the physical all the way up to the apps that are running on everything in between. So the physical compute, the network, the storage, compute, all that, the virtualization environment, that's VMware, whatever it might be, Hyper-V, and then you're responsible for maintaining the platforms themselves. You patch the OS, you upgrade the middleware, you install runtimes, you manage the data in a database or whatever that might be, and then you actually manage the applications, and then there's security and a lot of other things baked into that. Now, of course, with infrastructure as a service, you're basically responsible for everything from the virtualization up. So that'd be the OS, middleware, runtime, and data and application. You configure all this stuff down here. You might configure storage and configure networking, but you're not responsible for the maintenance and management of it. Microsoft takes that on when you go to infrastructure as a service. So you're no longer having to buy physical hardware or pay for licensing like on VMware. You're just using the cloud, and it does a lot of that those kinds of things for you. And then you basically focus on the operating system up from there. Platform as a service is a little different. You go from basically the runtime up. So you're responsible for data and application. You configure some aspects of the runtime so it'll support your application. So I need to tweak some things about the .NET framework, or maybe there's some settings I need to turn on inside of that platform. But by and large, you're not responsible for the maintenance of it and the patching and those kinds of things. Microsoft, in the context of Azure, takes that on. And then, of course, software as a service, everything is kind of managed by the provider. Now, Azure is really these two right here. This would be like Dynamics 365 or Office 365, which is software as a service. You're not really using you're not running your applications on Microsoft's environments. You're running their applications for your business needs, while this one you're actually deploying applications and maintaining them yourself. This one, you're just using the applications over here. Azure is infrastructure and platform as a service, in kind of the melding of those two, and that's so that you can run your applications, be it your software as a service provider or for your internal applications or your websites, whatever those might be. So that's what we're going to be focused on today, is kind of these two, infrastructure as a service and platform as a service. However, there's some middle ground in between there, and that's what I'm going to talk about on this next slide, and that's containers. So we have on-premise, we have an infrastructure as a service, we have platform as a service, but kind of in the middle, you have this idea of containers, which is still both platform as a service and infrastructure as a service, because there's not exactly clear where it falls into the mix here. And the reason I bring that up is because containers, you're responsible for some aspects of middleware and some aspects of runtime and some aspects of the operating system. However, you're not responsible for all of it. And so depending on the depth that you go into that, you're going to be building images, container images that have middleware as a part of that image. So you're going to be responsible for maintaining that. However, there's components that go along with that, that are middleware type components that are provided by the platform itself. So if you're running this on, say, like Kubernetes, for instance, there's middleware components there that are baked into the platform that you're not managing. And so you kind of have to take on what you own in terms of running the applications, but the actual platform itself is going to provide some of these resources for you. So it's kind of a shared responsibility whenever you go to containers. It's like more like managed infrastructure than it is a full-on infrastructure as a service or platform as a service. And of course, you're going to be responsible for your apps and data on top of containers. Now, this has pretty big ramifications. These are kind of the three major offerings I want to look at today. I want to look at infrastructure as a service, more from the perspective of, oh yeah, that's pretty obvious. Okay, I can run VMs on Air. I'm going to look at this one with a little bit more nuance, though, in containers and platform as a service, particularly around Azure App Services, to talk about why you might want to consider one of these over the others. So, because infrastructure as a service is pretty much a slam dunk for most people. They get that. Okay, it's like I just draw the line right here, and I migrate my VMs, which this is pretty much a VM right here, onto Azure. So I just take this stack, move it onto Azure virtualization infrastructure, and it's done. I don't change the app. I don't change anything. I just really kind of lift and shift as is, and I do that. That's a fairly common approach for migrating apps into Azure for folks that don't want to do any real mitigations in terms of replatforming an application, whether it be in containers or in app services. So that's a one that's I'm not going to spend a lot of time talking about. These other two are they have some nuance to it, and I want to kind of speak to those. So I do want to speak to these kinds of dichotomies that you have. There's like this, on this gradient down here, you have ultimate control and ultimate management of everything over here on the left. But as you move more to the right to this infrastructure as a service and platform as a service and containers, you lose some aspect of the control of the environment, but you have less management responsibility. So those are kind of the trade-offs between those. And those are definitely factors that you have to take into consideration whenever you're going into one of these different kinds of options that we're going to be reviewing today. And if you need that more fine-grained control, obviously you're going to prefer something more to the left. If you don't need that fine-grained control, you're going to prefer something to the right. Because the less that you have to manage, the less responsibility you have to take on, and that means you can spend more time doing other things, and you can let Microsoft do some of that management for you. And that's really one of the value adds of the cloud, is that you're no longer having to manage a lot of different aspects of your infrastructure or your platforms. You're kind of delegating that responsibility, and that's where you reap a lot of this cost savings as well, because you're not having to pay people or pay licensing for a lot of these other kinds of tools that we use for management and so on. So let's just talk about lift and shift. Now this is the first scenario that I want to mention here. As I said, lift and shift just takes a VM and moves it as is to Azure. Now, okay, maybe that's not entirely true. There might be some things you have to do that VM, but it generally speaking is as is. Okay, I'm just taking my virtual machine, I move it as is into Azure. And there's the tool that I would use for that is Azure Site Recovery. So Azure Site Recovery is a offering on Azure. I'm not going to be able to demo it because to demo this takes a lot of time and effort, more time than we have available in a webinar, really, to migrate a VM. But basically what it does is it starts with a discovery. You do a discovery of the VMs in your environment. And then from that discovery, you take that into Azure. You tell Azure, I want to migrate these VMs through an Azure migration project. And then what it does is it starts replicating the drives off of those virtual machines into Azure, bit by bit, and then basically copying the data out of the VM as is, and then into Azure. And then as you let it do that process, it also does deltas so that you don't have to shut the VMs down while that replication is happening. And once the VM is replicated, then you can migrate it. And what that migration does is basically just shuts down the old VM on premise and brings it back up in Azure as it was on premise in the same state. So it's basically a bit for bit copy of what it was using that replication process. And you can use it, you can move it off of a physical machine, or you can do it off of virtual machines hosted in VMware or Hyper-V, and the like. So it's a fairly straightforward way to do it, and it has a lot of the tooling. But again, it's not a trivial to set it up, and it does take a while to get the whole process working. So again, not going to be able to do a video demo for you on that, but it's just because of lack of time, really. Now, scenario 2 is that I want to talk about is platform as a service, and platform as a service is one of the major offerings on Azure that gives you a lot of value because it takes away a lot of that management responsibility, and you get a lot of features that are just baked into the platform that you don't really have to configure manually. It's just basically you go into the Azure portal or through some scripting, and you change some settings, and the platform will adjust its behavior for you. So if you want to, you don't have to worry about configuring a load balancer, for instance, or if you just want, or you don't have to install something like a high availability application setup. So you're not having to worry about node failure and things like that, because all of that's just built right into the platform. So the platform as a service is a very attractive offering for folks that are running in some of these commonly supported platforms like Java, PHP, Node, .NET, Python, and it also supports containers. Of course, we're going to look at that because that's a little bit more than broadly speaking, a little bit more broad than what you might do with Azure migration. Azure App Services. And there's a tool that you can use called App Service Migration Assistant. And we're going to look at this tool in just a second, but I want to walk through what exactly is an app service. So an Azure App Service is it's platform as a service. And basically you can host all kinds of things on it: web apps, mobile backends, RESTful APIs, and even use some things like serverless. If you're wanting to completely rewrite something, serverless might be a good option for you. Azure Functions would be on app services, but for the purposes of migrations, you can run web apps and web APIs and mobile backends for it. It's basically for web-oriented applications in that case. And you can bring all kinds of programming languages, as I mentioned, .NET, Node, Java, PHP, Python, of course HTML5, because you're serving up web pages. Then you can bring custom code with a container. And so that you can basically just package it up using something like, if you wanted to run Ruby, for instance, Ruby on Rails in a container, you can package your app as a container and deploy it to Azure App Services, and it will deploy it and run it right on top of App Services without having to, to spin up something like a Kubernetes cluster if you wanted to do that. So it does have that option, and it also gives you multiple deployment options. Now, of course, some of these are going to be less ideal than others. The canonical one would be obviously something like Azure DevOps or GitHub or Bitbucket, which are hosting platforms for code, and then you would build a DevOps pipeline to deploy from these, or Git, I guess. But you can also deploy from some non-conventional ones like just uploading a zip file or FTP, sync with a Dropbox or a OneDrive sync, just basically sync files back and forth between those. But the canonical ones are certainly going to be not Dropbox, but these right here, including a local Git, I guess. If you're building out a DevOps pipeline, definitely want to take advantage of those if you're using app services just from a deployment model. And of course, you can use Linux and Windows. It's got a Linux host that you can run Linux apps on, and a Windows host, and that's of course Windows being from Microsoft. The ability to run Windows apps is the first first offering, and then a few years ago they added Linux to that mix, and now you can run Linux hosted applications that are more Linux oriented, and you can also run Windows and Linux containers on app services. We'll again going to get to the containers in a moment, but the ability to be able to choose your platform with your operating system and basically get the same kind of behavior you would expect from either one of these offerings is pretty phenomenal, because it gives you lots of flexibility, lots of options, and a lot of variability in what you can host on this platform. Of course, it's not for everything. Of course, this is web oriented. You wouldn't be able to run applications that aren't web facing applications. In other words, you probably wouldn't be able to run an FTP server on this because it's not really oriented for that. You'd have to run that on some other kind of environment. And so if your application is in that kind of context, consider another option, because it won't work for the app services. So the architecture looks something like this with an app service plan. App service plan is basically just an allocation of resources, basically saying I want so much compute, so much memory, so much storage. And then you can divide that up among any number of app services, as long as you don't do resource exhaustion. And then within the context of app services, you have something called deployment slots. And then these could basically give you your HA story inside of, or scalability stories inside of an app service. where you can have multiple instances of your application running if it supports that, and it'll load balance between these different deployment slots so that I can deploy 1, 2, 10 instances of my applications. Then the load balancer built into App Services will load balance it between them. However, if your application doesn't support load balancing in that context, then you might have to think of something. You would probably only have a single deployment slot, and you can use deployment slots for like A/B configurations, or you can do deploy your new code into one deployment slot and then do a failover to an alternate one, and then it will start redirecting all the new traffic to the next version of your application without having to do a service interruption or something like that. So deployment slots are just basically enabling you to run multiple instances of your application in an app service. However, you can run your same application in another instance of an app service. You can carve this up however you want, as long as the resources in your app service plan support the applications you're running. You shouldn't run into issues. So you need at least one app service, but you can have multiple in a given app service plan. So the resources for an app service plan look like this. You basically buy the app service plan, and it comes with a predetermined set of RAM, ACUs, which are basically a relative score based on a Azure VM on Azure. So Azure VM with 50 ACUs, and that's a single core VM, very bare bones VM on Azure. And so you can go up from there. So 100 would be like 2 core, and 200 would be like a 4 core, etc. And then scale, how many instances you want to run. You have staging slots. That's getting back to those deployment slots. It does automated backups, and you can configure that. And then you have storage. And the breakdown looks something like this. And you have a free tier if you just want to experiment with the app service plans. And you have basic tiers, which have ACUs around 100, 200, or it'd be like a 2 core, 4 core, 8 core, and then RAM divided up, 1.75 gigs of RAM, 3.5 gigs of RAM, and then 7 gigs of RAM. Then the standard offering, similar, but this one has better storage. It's got faster storage on it, and this one also has auto scale features right here, and that's a differentiator. It's got better compute too, so more reliable. I should probably say that. And it also does automated backups, and it also has 5 slots. And then premium, of course, is probably going to be the one that's most oriented for larger applications and folks that need more performance. And you can get these start off at 210, 420, and then 840, and then you can scale relatively easily on these and get backups, etc. So app service plans and app services are a very attractive offering for folks that are really thinking about going into the scale. I'm not going to talk about that. So let's look at the App Service Migration Assistant. And this is a utility that will help you decide if you can go into app services or not. So let me get my my VM up here. Now, I have a VM here configured, and this VM has an app running on it. So let me just show you my little app here. Let me go and launch Chrome. And I must be running this on a spinning disk because this is kind of slow. Let's go to HTTP localhost just to see what this looks like. This is the site I want to migrate. This is my app I want to migrate. This is just my demo. Let's see what this looks like. Okay. So this is my application. It's an e-commerce website. This is the app I want to migrate up to Azure, and it's running on an IIS box in a local context. So to migrate this, I need to run the App Migration Assistant utility, which is going to give me the output that I need for migrating this into Azure. So I'm going to launch this here. I've already installed it, and let me go ahead and launch this utility. Now, what this utility does is it does two things. It does an assessment, and it does app migrations itself. And so the assessment report is basically going to tell me the state of my application and in its current state, and whether or not I can actually move it into Azure. And so let's just start with that. I'm going to start with the default website here, and let's walk through this. And it's going to run this utility to look at a couple of different things here. It's basically going to tell me everything that I need to know. Is looking for all these different ports, IS API filters, tags, content, different kinds of things that might prevent it from moving into Azure. So it's basically just looking at a checklist and then looking at the configuration. And depending on the complexity of the application and the size of the application and a number of other things, it might run fast, it might not. It just depends on what you're doing. My application has no issues. So this is happy path. If there were errors, you would see that here. I was working with a customer this week and ran this utility, thinking that their application was going to go to Azure without any problems. I ran this utility just to make sure, and it found some problems that would prevent it from going to App Services. So just one of those things that it's going to do a very thorough check of things that it's considering on this particular website. So let's go through the next. Now I can actually move it into, I can actually move this application into Azure using this utility as well, assuming that everything checks out. So if I go, I can just use this utility, create an app service. Yeah, let's just log in. And it looks like I'm already logged in. Yeah, continue. And I should be able to use, it's going to give me the ability to choose a subscription here. Let's use that one. That's basically you get a migrate project on Migrate Hub. And then you can choose a subscription you want to move into. So I can create new My eWeb. I'm going to call that, and I'm going to use this sponsorship certificate. Let's see if it, let's just call it Blaze Web or something like that. That way, choose a region, skip the database setup. I don't need that because I don't think this site actually has a database because it's more for demoware than anything. And what it's going to do is it's just going to allocate the resources on Azure and actually do the migration for me. Now, the migration process can take a few minutes to do depending on the size of the application. And it looks like there was an issue with this one right here. We'll see what the output of that is. But if it's a larger application and you're thinking about using this utility, it might not be the best one to use because there are issues with size and other things like that when moving apps using this utility. So the real value of this particular app, though, I think is the assessment report. It's not the migration side of it, although that can help. I think the assessment that this will do for you, regardless of the size of the application, is really going to be the best bang for the buck on this particular application. And so if you can use it just to run the assessment, that's all you need in many cases. And once you have the assessment done, you can look at the results of that. So let's, it's basically just copying the content up to an Azure App Service. And we'll let this do its thing, and we'll come back and revisit it in just a second so that we can move on with this so we can look at the rest of the content. We'll check on this in a minute. So let's go back to our deck and take a look at that. So the next scenario I want to talk about is containers. Now, as I mentioned, containers kind of do the kind of flirt with that platform as a service and infrastructure as a service. They kind of ride the line between the two. And I wanted to kind of treat these as a separate way of migrating apps into Azure because you can run these on app services, but there are other ways to run containers on Azure. And there's just, there are 5 of them listed here. And actually, I think there's more than what I have presented, but there is a lot of varying offerings on Azure that will give you a running container, and they have varying degrees of complexity and value add to them. But the bottom line is you have a lot of flexibility with containers in terms of what you can A, put into the container, and B, how you can run the container. And so I'm going to look at it from that angle. So this is probably the middle ground between, I can't run it on app services, but I don't want to run VMs anymore. So I can containerize it, and I can containerize most anything. It's not, there are exceptions to that certainly, but this is of course not a universal rule here. But it's generally speaking very doable. So let's talk about these different offerings here. These are all the offerings, as I mentioned, that you can use on Azure. An Azure Container Instance is obviously the most basic one. It's for smaller container workloads, building using a consumption-based model. In other words, it's built basically on a time basis. So they take the amount of compute you use, multiply it times the amount of time you have, and it's basically billed by the second. It's rather than like an hourly billing cycle. or monthly billing cycle. It's basically you start the container, you run it for a while, and you shut it down, and you're billed only for that period of time down to the second. And so it's kind of a sliding scale on how much compute you use, but that's how it's metering it. And so it's very much intended for kind of transient workloads. However, you can run full scale workloads in container instances. I don't think I'd recommend doing that way, because if you need that kind of compute, you might want to consider using container app services on containers or Kubernetes in that context. This is good for batch style workloads that you spin up, they run for a little while, and they shut them down. And I'll do a demo of this one in a little while, just because it's easy to do. It's super easy to spin up, and it requires very little thought. These require a little bit more planning, because app services for containers requires that you spin up an app service, you manage that, and then you build a container and deploy it. But this again is this is for web-oriented workloads, and it's not nearly as robust as something like Kubernetes. And when you start to go to like Kubernetes or Azure Service Fabric or Red Hat OpenShift, now you're talking about full clusters here. This is Azure Kubernetes Services is what I might call managed infrastructure. It's exposed to you. You can see the infrastructure it deploys, but Microsoft is doing most of the maintenance on that and managing that infrastructure for you. It's a shared responsibility, kind of getting back to that shared model that we're talking about. There's some things that you have to take ownership of, and there's things that Microsoft does for you, and you have to do a partnership in running Azure Kubernetes Services. And so they're going to maintain a lot of that for you, but at the same time, you kind of have to be aware that there's certain things that you're going to have to do, like maintain the version, or if you apply custom configurations to Azure Kubernetes Services, then you might have to manage those configurations and like installing ingress controls. There's a lot of things that we could talk about there. Azure Service Fabric is another offering, and this is Microsoft's homegrown orchestrator for microservices and containers. It's marketed as a microservices and containers. It's mostly intended for microservices. This one is basically for folks that are already using Service Fabric for something and they want to add on containers to it. If you're going to start greenfield in containers, I would go with Kubernetes, because Red Hat OpenShift is containers. This is Kubernetes as well. This is Kubernetes with value add, but what Red Hat does in OpenShift is it does a lot more of the management of the cluster for you than what you get with Kubernetes services. In fact, it doesn't really even expose the infrastructure to you like Azure Kubernetes Services does. And there's also CI/CD tools and things like that baked into OpenShift. And so it's a useful tool if you kind of want a full-blown orchestration engine plus all your kind of DevOps stuff to go along with it. And that's kind of what Red Hat OpenShift brings to the table as value-added services to a standard Kubernetes deployment. And so you get a little bit more of a managed experience with OpenShift. Kubernetes services, like I said, managed infrastructure. So these two, just to recap, this one's simple, this one's moderate, these three are complex, but in all of them can run the same container. So if I create a container that runs on container instances, it's going to run OpenShift or Service Fabric, what have you. They all work kind of the same way. So what does a container look like? A container looks like this relative to a virtual machine. If you've never been exposed to it, basically the difference between a container and a virtual machine is where it does the abstraction. So with a virtual machine, you have abstraction at the hardware level. And so you have a hardware abstraction layer that comes in right here, and then you install guest operating system on virtual hardware. With containers, it does it at the operating system level. So instead of a virtual hardware, you basically get a virtualized kernel experience, and therefore you don't have to have a guest operating system. The trade-off with a container is basically that containers are bound to the operating system that is hosting them. So there's an operation system affinity associated with containers. So Linux containers have to run on a Linux host. Windows containers have to run on a Windows host. However, if I run an Ubuntu container on a Red Hat host, I can do that. If I run a Red Hat container on an Ubuntu host, the distro of the Linux version of the distro, or really getting out even to the version of Linux, is really less important at that point. So if you want to use Ubuntu based images as all the base images for your application, you can deploy that to a Red Hat host and it'll work just fine, and vice versa. Or you can use some other distro. There's a lot of different options there, and depending on what you're doing, one distro might work better than another. So that's for folks to kind of pick and choose how they want to run that. Windows, it's kind of the same story. Although Windows containers are more of a niche case in the container space, you basically deploy your application to a Windows host, and you don't have to worry about the configuration of that Windows host because all the configuration and all the applications and stuff are basically baked into the container. And that way you're not having to worry about how is the underlying operating system configuring IIS. Rather, I'm running IIS in a container, and I just configure IIS in that container context, and it'll run the same regardless of what Windows host I deploy that container to. And so that's kind of what containers are getting at, is just a virtualized kernel with all the other things on top of that kind of abstracted away, so that you don't have to worry about it. So what does a container flow workflow look like? It's pretty straightforward. You have something called a Docker file, which is basically a script that tells you how to build a container image. You run Docker build, and it takes that script and creates a Docker image. Then you do push, and that takes it and pushes it up to a container registry. The container registry is an online repository of images that you can deploy to a container environment. So all of those container environments that I mentioned earlier, container instances, app services, Kubernetes, Red Hat, Service Fabric, all pull from the same kind of thing. They all pull from a container registry. And so the container environment then will deploy that container. It's going to pull the container down to that local environment, and then it's going to run that container image as a container. And so now I have a container up and running. So this basic workflow is kind of how they all work. And so you have the build environment, a container registry, and a container environment for running those containers. And so I can use any number of combination of tools to A, build images, and or B, deploy and run images. So there's largely a good separation of concern between build environments and container environments over here on the left. And so this allows me to use very different tooling over here for building and pushing. It's fundamentally all Docker, but if I wanted to build on, say, something like GitHub, or I wanted to build something like an Azure DevOps, I can do that. It's kind of my build environment, and then I can deploy to any number of other environments, such as Azure Container Instances, App Services, and so on, like I mentioned earlier. So lots of options for orchestrating this container workflow, but it basically all works the same way. So let's go check on our other demo that we're doing, and I do want to run this application, do a container build, and then push it, and then do a container instance deployment. So let's go back over here and see how things look. Okay, looks like my migration finished. Let's go to my website, and let's see if I can launch my my little e-commerce website here. Okay, so I migrated my e-commerce. The Azure Migration Assistant successfully migrated my app into Azure, running the using the Migration Assistant. So yeah, that's not too controversial there. Let's take a look at containers, though. I'm going to pop open Visual Studio here, and I have the source code for my e-commerce website right here. And again, you don't have to have the source code to build containers, but it is helpful. So if I wanted to run this locally, I can run it in Docker. Yeah, that's what I just did. I basically what this is going to do is build and run a Docker container locally on my dev box here, and this is where I'm building the image, and it's going to start it. I can also run this in IIS. So I'm basically running the same app on my IIS instance, and I push it up to App Services. I can run it on a VM, obviously, because that machine I was connected to a minute ago is a virtual machine. And this debugger, yeah, I didn't think that was going to work. Let me change this to. Oh wait, did it launch? No, it didn't. Okay, let me change this to IIS Express and run it that way, and then we'll do the container build separately. just so that we can validate that this actually works on my dev environment here. So come on, this should work. Let's see what's going on. All right, there it is. Okay, there's my website running in my local dev environment. Now, I'm gonna consider this dev environment my my build environment for doing something on Azure. So I'm going to stop this. And basically what I want to do is do a publish. Now what a publish does in Visual Studio is it's going to push it up to a container registry. So this is going to build my image and then push it. I've already configured this to use Docker Hub. And Docker Hub is a container registry that you can use for migrating. And so this application, if I was going to migrate this into Azure, I would need to containerize it as this as using the tooling that I have available, and it's going to build basically a Docker, what's called have a Docker file. It's going to look something like this, and it's going to compile my code and then publish the code into a container image and then set all that kind of stuff. I'm not going to get into the details of all this because that would take a while to unpack what all this does. But in any case, I do want to publish this just to do a quick publish here. And I've selected my Docker registry as my destination here. So I'm going to click publish and watch the output from the console here. That's kind of what I want to do, because this is where it's going to start building the project, and it should launch a console window here in a minute to do the push. So it's building it, building the code, and now it should launch a console here. Okay, it's actually building not building the console. It'll launch a console to do the push, but it's actually building the image down here in the output for Visual Studio. That's what all this is doing right here. That's the build process for the container. And so this is setting that up. And once that's all done, I should get a push. I've already pushed this particular image up to Docker Hub, and I think that I did that just to get prepared for this particular demo. So I'm going to launch Chrome here, and I'm going to go out to Docker Hub just to see what that looks like. I think it's already there. It's just to make sure. Blaze, because that's mine, and that should take me right to it. And it is this image right here, Blaze. This is the image I'm pushing to Docker Hub as of right now. And let's see, let's check our progress here, how we're doing. Okay, it's still working. But given that I published this about an hour ago, I did do a push just to make sure it was there. I can go ahead and start the deployment of this one. So to do that, I'm going to go over to the Azure portal, and I'm going to create an Azure container instance for that image. And since it's already there, I don't have to recreate it. And let's create a resource. You come over here to containers, container instances, and let's create. That's fine. Let's do create a resource group called Blaze CI, and container name. And I want to call my container eWeb, eShop Web. And sure, let's use Docker Hub with a registry or other registry, and I can put in my image name. It's Linux host, 1 vCPU should be fine, and 1.5 gig of RAM. That's where I'm setting everything up. And once I have the networking, I public endpoint, port 80, this is fine. Let's go ahead and make sure everything works, and create. And that should start the creation of that container instance. So that should allow me to run my website, my application in a container on Azure using something that's fairly easy to just spin up and create. Given that this is a very trivial demo, this shouldn't take too long. I don't think that image is too big. It's doesn't really tell me. So for some reason it says I have 100,000 pulls on this. There's really nothing in that. It's just a image. But sometimes the back end, if you pull those images, it'll start doing a lot of churn on it. Okay, it looks like that finished. And let's see if we can get this IP address. There it is. I don't have a FQDN or fully qualified domain associated with this. And let's just put in the IP. Let's see if that pulls up my website. There it is. So that's running in a container on Azure. So I deployed both to an app service. I know it runs on a VM. I know it runs in a container. So those are three different options for running for migrating to apps into Azure. Now, this app happens to run on all three, but that doesn't mean that every application can run on all three. Different applications will have varying degrees of compatibility with the services that you choose to run. Now, I can't tell you if your app's going to work on one or the other. You'd have to do the analysis, and that's where that tool, like what we saw with Azure App Service Migration Assistant, is going to give you an assessment report. Oh, yeah, that'll run on app services. If it doesn't, then containers might be a good option if you still don't want to manage VMs. And the VMs, of course, are going to be able to run most everything because it's fully controlled environment that you have control over. So let's go back to the deck and take a look at a few more things that I want to talk about, and then we'll wrap it up. Of course, fourth scenario is mix and match. You can mix infrastructure as a service, platform as a service, and containers for different aspects. I know folks that have done this, and in reality, for large applications like that are really systems, that's usually what ends up happening. Is you'll have a fair amount of stuff running in containers, or you might have a fair amount of stuff running in platform as a service, or you might mix some mixture of containers and platform, or maybe some platform and infrastructure, where you have some workloads that are going to run on VMs no matter what, and you just have to put them on VMs, and you run most everything else on platform as a service. But fortunately, the ability to integrate those is there. So what you can do is you can use something called private endpoints on Azure to get you the platform as a service offerings connected to the same virtual networks that you have on Azure, and they can be reached from virtual machines, and then the app services themselves can reach across that private network and access resources over a VPN, over an express router, things like that. So you can mix and match these, even if it's platform as a service. You can still attach it and use these in an integrated experience there. Now, this is kind of the process that you want to do to analyze an application for migration, to break it down. You kind of start with the application components. You want to look at what do the databases look like. We didn't talk about databases. That's migrating databases is a whole nother topic, which should take another webinar, which might do that one in the future. And then you look for things like file services. You look for forward-facing components like web application firewalls and load balancers. Then you get down in the application code. And this is where you're going to be looking at the components that go into making an application work. Is it a single page application where I have API backends? Is it something that a mobile app is hitting, and it's just a web service like that? You want to kind of tease out those components and look at those and understand what are all the various components of it. So you want to identify what are the forward-facing components, what are the back-end components, what component composes the application in terms of the code packages that I'm actually deploying. Then you also want to look at things like the hosting environment. Is it Windows? Is it a web host? Is it running on something like IIS? Is it running on something like Nginx? What does the web application hosting component look like? And you want to get an understanding of how that's configured. And then what the application stack? What are the idiosyncrasies of that? Java, .NET, PHP, Node are all pretty standard. So there's not a lot of rigmarole you have to do to get those applications running on app services. However, if you're doing some kind of tweaking of those environments, there might be some things that you might need to consider within the context of whatever platform that you're using there. And then what you want to do is create a logical application architecture. And basically what that is basically taking all these different components and mapping them out on like in a Visio diagram, and showing how they all connect together. And then you might have something that says, okay, this part will run on app services. Database is obviously going to have to run on some kind of database platform. I need file services. Maybe I have to do some refactoring of my application to make it run on something like blob storage or something like that. But all in all, what you end up with is a logical architecture of what that application looked like. And then you take all of the pieces of that logical architecture and you map components from Azure onto that. So that's kind of the high level process that you use for breaking down the application and then mapping on Azure resources. So you kind of map, this part's going to run app service. This is going to run on a database. This is I need a web application firewall in front of it, maybe a load balancer, whatever it might be, and you kind of figure all that out, and that creates what you need to create on Azure for the given application that you're trying to migrate. So here's some common resource mappings for APIs. Of course, these are the kind of things we looked at today. Backend jobs. You can run these on these offerings here: web jobs, app services, and so on. Load balancers. You have a traditional layer 4 load balancer, then Azure Application Gateway, which is an HTTP based or layer 7 load balancer for apps. And then for file services, you have Azure Storage Accounts, which can give you SMB shares and things like that. And then you have Azure NetApp Files if you need enterprise grade, highly scalable, high performance file shares. And that supports like NFS and SMB and other protocols like that. And so file services might be something like that. And of course, data services for databases. And there's a ton of offerings on Azure for open source databases as well as SQL Server. So you can run Azure SQL, SQL Managed Instances, SQL VMs, Azure MySQL, Postgre, MariaDB, and of course, if you need MongoDB, you can use Cosmos. And then you can adopt Cosmos DB's APIs as well if you're going more greenfield. But again, lots of offerings on Azure for mapping resources. These are just some of the common resource mappings that you might consider whenever you go to deploy your applications onto Azure. So the next thing you need to do is try to figure out what your priorities are. So the technology is a big part of it, but there's also a lot of other things that you have to kind of take into consideration when you move into an environment like a new environment. And these are the priorities that you have to set. And it's like agility, how fast do I want to move into the cloud? Flexibility, how much leeway do I need in my environment for adaptability? Flexibility is a big deal. If something's not flexible, you might have to do some mitigation to make your application run in a specific environment. Management, how much management responsibility I'm going to take on for my applications. Again, platform as a service is going to be less management, but infrastructure as a service is going to have a lot more management. Tooling, what tooling exists to help assist and expedite app migration? We looked at one tool, the Application Migration Assistant. And there's other tools out there that can help you do assessments. Like if you want to do some static code analysis, or if you want to do some kind of dependency analysis, those tools exist. So if you want to run something like SonarQube for static code analysis to kind of see how your code maps out, or you can use Dependency Walker to kind of see what DLLs and whatever components your applications are using. Another one is familiarity. And this is oftentimes a big deal for companies that aren't familiar with something like Azure. They're not very comfortable with new technology, and their personnel isn't. So they're much more comfortable managing VMs than they are managing new environments like Azure App Services. So they will opt to go to VMs on Azure for migrations versus using new platforms and new tools, because to learn that takes time and effort. So they just say, hey, I just want to stick with what I know and go with that. And then of course, cost, how much, that's a big one. Organizations don't want to spend a lot of money on the cloud. They want to save as much as possible. So choosing lower cost technologies like platform as a service over infrastructure as a service. And so these are all priorities. You kind of have to prioritize which of these that you want to use and which one's going to make the most impact. And you kind of have to choose, well, I need to prioritize agility and cost or over familiarity and management. I don't know, I'm just picking those arbitrarily, and you kind of set those priorities. And then when you do, you kind of look at the options that we looked at. So you look at things like agility and containers and platform as a service. So depending on what you're doing. So agility, obviously, if you just want to lift and shift in the cloud, one of the simplest ways to do that is just to migrate a VM. Now, it's not the most cost-effective way, but it'll get you to the cloud fast without having to do a lot of mitigation or replatforming. Containers can be fast as well, but sometimes you have to do a lot of uptick in learning new tech or spending the time to learn how to containerize applications. And platform as a service, Can be fast if there's no mitigations. Like with my application I was running in my demos, I had to do nothing to make that run in app services. But it can also be very slow because sometimes you end up having to do a lot of remediations to your applications to make them run on app services. And that can be, for some people, a blocker for moving into app services. And flexibility, it kind of goes along with the same vein. High infrastructure, a lot of flexibility there. Containers are a little less flexible, and then platform as a service is what we call very opinionated. It's not going to be able to change to your liking. You kind of have to change to how it works. You have to adapt to how it works versus the other way around, adapting it to how you work, which is what the infrastructure is going to give you. And of course, management, the more flexibility you have, the more the more management that you're going to have take on. Containers have moderate management, of course, minimal management for platform on the flip side of that. Tooling, again, this has got great tooling. ASR is a great tool. Lift and shift, run a discovery tool. It's time consuming to do that, but once you kind of get the automation going, you can kind of just say, start the automation and then go to bed and then come back the next day and then you have migrated VMs. It's kind of like that. It just takes time, but it doesn't take a lot of sitting there, watching it or just kind of pouring over multiple retries to try to get things to work like you might have to do with containers or platform as a service. This has got a lot of tools associated with it. There's just a ton of tools for containers. Sometimes it's hard to know which tool to use. And there's many pre-built images, but you kind of have to work through a lot of the idiosyncrasies of your app to make it work in a container. While Platform as a Service has tools for analysis like Azure App Service Migration Assistant, which we saw, but it might require some refactoring of your application in the event that your application isn't compatible with the platform that you're trying to put it on. So those are some of the trade-offs for tooling. Familiarity, lots of folks, VMs have been around. They're very mature. They've been around for the better part of 15, 20 years now. Folks are very familiar with it. Containers are getting more familiar with folks. They're kind of been around for about 5 years now, started around 2015 or so. And they really kind of took off, about 2017, 2018. They weren't just kind of a niche thing anymore. They're kind of mainstream. So they're still less familiar to some folks, but they're becoming more mainstream. And then the same thing with Platform as a Service. It's just, folks that are thinking about migrating to Azure are probably not going to be very familiar with Azure, so it's going to be less familiar to them. And then, of course, cost. This can be very expensive, just infrastructure in general, because it's not just the cost of the compute, it's the cost of managing the compute, the licensing, the personnel, and everything that goes into managing infrastructure. That kind of makes that whole proposition very expensive. This one over here, the actual compute might be more than what you pay for if you're just running an equivalent virtual machine, but the overhead needed for that, the patching, the management, the personnel, all those other factors that you have to take into consideration are no longer there. So it can be a total cost of ownership can be lower. And same with containers. Because a lot of that is a managed experience for you. There's less management involved, so it's generally going to be a total cost of ownership. It's going to be less than what you get with something like infrastructure, but maybe slightly more than what you get with Platform as a Service. So those are the options. So we kind of looked at the technical. We kind of looked at the non-technical aspects of migrating this, and so technical. Is all the tooling, all the technology, all that. And then there's the non-technical things, which are things like business priorities, like flexibility management, agility, familiarity, and cost. All of that helps drive the decision making for going into whatever path you choose to migrate your apps. And so you kind of have to think about all of these, and then choose your priorities, and then focus on focus on a platform, and then adopt that platform and migrate into it. So given all this, the rubric that is basically trying to figure out which of the three options that we've kind of presented here is going to be the best fit for your priorities and for your technical abilities and the technical demands of your application. And then after you kind of do all that analysis and you do the sifting, one of these will likely come out as a clear winner. And you do have the option to choose those. So I do want to open it up for these are some pain points. I just want to point some of these out. Um, Technology choices may require options that go against priorities. That's basically saying technical choices like mitigate, like app remediation. If you want to move fast, technology choices may require options that go against priorities. So you might have to, if you want to move fast and your app requires remediation, that's going to require you to go to something like VMs or something like that. That's kind of what that's getting at. Different teams may have different priorities. So that's kind of a decision that has to be made from more of a management perspective. Let the business drive that. Priorities can compete with one another, and that's why you kind of have to prioritize the priorities, choose which ones are the most important, and let those kind of be the drivers. Another thing that you don't want to do is let technology drive the decision making. Let business value do that. Business value should be the ultimate driver of any decision making process as you go into that. And part of that business value is like, how fast can I get to the cloud, and what's the cost, and etc. And that should be some of those should have higher priority than technology specific ones. And then getting into analysis paralysis, fear of the unknown is a big one. Finding the perfect solution, because ultimately with cloud there really is kind of never a perfect solution, because you're really ultimately using somebody else's computer, and so you have to kind of adopt some of their assumptions and some of their opinions about things to make your applications work. And so there might be some little idiosyncrasy about how Microsoft manages VMs that makes even the VMs options on Azure not be the most ideal option for you. But you generally kind of say, hey, I can live with that. I can live with those assumptions, and I can make those work. So in any case, migrating, making sure that you understand what you're getting into, and then struggling, doing the analysis and getting that kind of on paper and figuring that out. And then lastly, migrating too soon. Migrating an app is kind of the last thing you do on an app migration. There's a lot of other things you do before that. Building that Azure landing zone and getting all that squared away first. That's your governance and security. Once you get that squared away, then you start doing your app migrations, because that has bigger impact on the overall environment that you're going to be working with on Azure. So I know we've gone about 3 minutes over, but I do want to take time for questions if we have them. So if we don't have a lot of questions, that's okay. Somebody gave some information back there. So generally, isn't it more expensive if you lift and shift infrastructure as a service on Azure? Yes, it is. Basically, if you're shifting the cost from one on-premise to the other, should you keep an eye on cost? And that's a big factor. Infrastructure as a service is, generally speaking, more expensive than a platform as a service, and it's something you do have to keep an eye on. Now, what is it more expensive than on-premise? That depends on the nature of the infrastructure that you have on-premise, but you do need to make sure you keep an eye on what you're doing. If you're shifting costs from on-premise to the cloud, so keeping an eye on the cost is a big factor. Yes, that's a priority. For some people, like the overhead of managing infrastructure on Azure is one of those pain points that folks have. So they don't. It's just for lack of familiarity or what have you, and that can be an expensive endeavor for them. For other people, like they think of infrastructure as a service as a cheaper option, because they're paying a lot of money for people to manage very specific products like VMware environments, or specific firewall options like Palo Altos or FortiGates and things like that, where finding the qualified people to manage those kinds of things can be very expensive. So they figure, if I go to Azure and I use some of their products and some of their security offerings, I can kind of lower that cost and still maintain the virtual machines, but use some of those first-party services that are more as a service offerings in front of virtual machines and things like that. So there's a lot of ways to kind of mix and match infrastructure and platform as a service in order to kind of lower your total cost of ownership. And so, because it's not always Azure spend against on-premise, because there's a lot of factors that go into determining what is the cost of ownership of anything. But generally speaking, using in the cloud services has a lower total cost of ownership than using on premise. So that's my 2 cents there. Well, if there's no more questions, I think that was the only one that was kind of put up here. I'll post. We'll be posting this to our YouTube channel, so you can definitely check that out. Also, if you want to reach out to me directly, I'd be glad to share the deck with you or any other questions you may have. Feel free to shoot that to me. One other question did come up here. Um, um, what criterion is there for choosing between Azure Load Balancer and Azure Application Gateway while migration? Okay, Azure Load Balancer is a layer 4 load balancer, meaning it's a TCP load balancer. Application Gateway is an HTTP load balancer. So one of them is more context aware of the application. So if you're running a web-based application and you want to use like a URL-based routing, or you want to use session-based affinity, or you want to do things like that, that's where using something like an application gateway would be advantageous over something just like a pure TCP load balancer. Because TCP load balancers don't understand that kind of thing. They're just saying it's a TCP packet. I'm going to send it to I'm gonna load balance based on the session, the TCP session, to this endpoint or that endpoint. A TCP load balancer can be used with any TCP or UDP protocol. It'll work with FTP, it'll work with HTTP, it'll work with anything. While a layer application gateway or layer 7 load balancer for HTTP would only work with HTTP protocol. So maybe that's kind of the differentiator between the two. The thing I like application gateway for app services and other options like that because it has a built-in web application firewall with it as well, so you can use it for security as well as all the other features it has that are specific for things like HTTP based workloads. And so it's kind of a given to use application gateway for that. But if it's just TCP based, yeah, then that's going to be the load balancer, just the standard load balancer. Hopefully that answers your question there. So if there's no more questions, I'll gladly feel free to shoot me an email. You can reach out to me there at blaze@winlock.com, and or you can hit me up on Twitter, or you can feel free to hit us up on our YouTube channel, and you can definitely see a replay of this video there as soon as we get it posted. So thanks for coming, and look forward to seeing you on future Wintellect webinars.